Right, so the bulk density measurement is mass over volume. It tells us how dense the soil is. That's helpful if we're having issues with compaction potentially, like root penetration, water soil movement, and it is one of the essential things that you need to know to measure soil carbon stock. So there's more interest in that recently. If you imagine taking a core, a slice of Wonder bread, some white fluffy bread with lots of air in it, or taking a core of a piece of dark rye bread, which core of the same size has more calories and carbon in it? The rye bread. Is that one, like, you just know that's more dense, right? There's more stuff in there per volume. So to measure bulk density in soil, we need to take a core that we know the volume of, and then measure the mass that's in that. And so there's lots of different ways to do it. The tools that we've been using in Vermont are here. The first one is a slide hammer. So the slide hammer is the upper part, and it allows us to hammer in the core into the soil. And in the core, that's the part where we're going to take the measurement from. This is just for demonstration, but the slide hammer lets you hammer it in, and then also lets you hammer it out. And these tools tend to break here if you rock them back and forth when they're deep in the ground to pull them out. So if you end up using one, take a shovel and definitely back hammer to get it out. So after you pull it out, you will untwist the core from the hammer. And here's one we took just a couple minutes ago from here. So in this one, we have two inner cores, and there is an important reason for that. After we took it out, we sliced off this end, so we have kind of an intact core that's exact, that the soil would be in this volume. And then we sliced it here as well, because the top can either get over compacted or maybe not be hammered deep enough to be full. And so we don't want to be stuffing soil in or have gaps there that wouldn't have been there otherwise. So you use the knife to slice it off perfectly, and if we were taking a measurement, we'd do a better job, or we'd have to retake that if that's how it came out. And then you'll put the caps on, and you can take that to the lab, and they just oven dry it to get the mass. The other tool that we have to show you today is this Giddings. It's very similar. It has a liner inside this. The head is connected by a pin rather than by a screw, and you hammer it in with a sledgehammer. It's definitely a little more rugged, less likely to break. And these we've been taking to a foot depth. That's the international standard for measuring soil carbon stocks, is to a foot depth. We wanted to see how some Vermont soil stood up to international measurements, so we did that. Any questions about what bulk density is or what I just showed you?
What if you can't get it down to a foot?
If you can't get it down to a foot and you wanted to measure to a foot, then you can't force it. So you could take a shorter depth core. So ideally you'd be going out with your foot core, that's your goal to take it. If you can't get all the way down, then hopefully you brought some shorter cores so you can measure density above that, and you'd have to make a note of that.
Or maybe there's an opportunity to take one, a more shallow one, but not disturb past like 8 inches, and then start there again. Like maybe you could take it from 8 inches down to, you know what I mean? Like just shrink the distance that you have to.
I thought you were talking about like if you hit bedrock or something, then you just stop.
Well, yeah, I don't know. Sometimes I'm out soil sampling. It's really hard to get down.
It can be really hard, yeah. So you can take a stratified sample where you're basically taking 2 short cores, and then you'll have different measurements there. Absolutely. Yep. UVM Extension has a number of these tools. So if you're interested in measuring this in any of your work with farmers or projects, you could reach out to Heather's office or Abby's office. AFT also has a set in a couple states in New England. Okay, so next we're gonna learn about Canopeo with Abby.
Okay. Has anyone heard of the app Canopeo or used it? Great. So Canopeo it's a wonderful app. It's available on your phone, iPad. It's also web-based, and it measures living surface cover. So we know that living surface cover is really important to soil health for a few different reasons. One is it's physically protecting the soil surface, which helps mitigate the impact of precipitation. It slows down any runoff, improves infiltration. So it's really great for both soil health and water quality. but it's also really important because it, you know, those living roots are feeding the soil biology and really sustaining that microbial community. So I found measuring, you know, living surface cover really important, especially around evaluating cover crops or different management practices around cover crops, maybe evaluating hay fields. And I'll walk through how to use it, and then we also have iPads that y'all can try out. But you know, within the app, you can physically take a photo by clicking the camera button, and you would want to take it by holding out the device about, you know, shoulder height and taking the photo. And what it's doing is it's measuring greenness, right? So, you know, in this case, we do have some bare spots that, you know, that's not going to be detected, or even sometimes yellowing material, right? Like that won't be detected as green. And then what it does is it produces, you know, a black and white photo where the white is the living cover, so the green, and the black is the non-green. Y'all will notice there is like a calibration dial that you can tweak at the bottom if you like compare it to your original photo and find that it's not lining up. You can tweak that a bit. But yeah, it's a really great tool. So this was about 52.5% soil cover. And then what you can do is you can log other information. What's the vegetation type? What's the conditions? What's the height? So you have all that information for you later. And if you go online, you can actually export all of that into a CSV or Excel file, which could be really valuable. You can also batch upload photos that way. So even if you're just taking photos on your phone, you after the fact can, you know, plug them into the web-based Canopeo. So I'm going to hand these out. Folks can play around with them. But we also are going to have the Penetrometer later. So especially if you haven't used a Penetrometer before, please come pick one up and play with that.
Oh, like sorry, when I say calorie, I mean like that was the wrong word to
okay.
use. How do you the word is escaping me. When you like take a small sample and then it is representative of the larger field.
So I would never take just one sample, right? Okay. It's similar when you're soil sampling a field, right? You zigzag through it, and then you're gonna get multiple data points and average that together. So I would definitely encourage that approach as well. You can do it a few different.
For how many samples, like how many pictures or whatever?
There's probably a number somewhere that I don't know. I've used it more on like plot scale, so I think I've done like 10 per plot.
Yeah, I got my boots in there the first time,
easy,
and I'm like,
to do, and in that sense, full transparency, I would take it on my phone and batch upload it later. I just found that to be more convenient, and I would also do it with a quadrat, and that way I could crop the photo around the quadrat. But yeah, I mean, I've done it both by zigzagging, or you could do like point intercept method where like you have a few lines that go, you know, across the, or perpendicular to like the slope of the field, and then hit, you know, 5 points along each transect.
The old way of doing it was just like setting up a string, right, and counting how many plants along like so many feet, like whenever there was a plant on it, right? So this is just much easier than that.
Yeah, I mean, there is nuance to it, right? Where it's getting at like a slightly different thing, because we're not getting plant density or population. So something, especially if you're monitoring in hay fields, to keep in mind if, you know, you mow and then take a sample or take a photo and then wait a month and take another photo, you're gonna have a very different value, even though you have the same plant density in theory, just because those plants are bigger. So definitely encouraged to, you know, record plant height and keep that in mind. But it does make it really easy to, you know, rapidly collect data, and it's just one nugget, one way to look at soil health, like amongst all the other metrics as well.
So sorry.
No, you're good.
Lots of questions. So how would you use this metric? Like, obviously you can have a lot of green, but like not a lot of biodiversity. So is it just like the amount of biomass?
Yeah. So one of the main ways that I have found it valuable is evaluating cover crop seeding rate and planting time. Where it is linked to biomass, like we want a certain amount of surface cover going into winter. We also, there is a relationship between that surface cover and eventually biomass. So I've used it as a valuable tool to kind of evaluate management treatments, so to speak.
Cool.
I remember there's like a little statistic of like 30% soil coverage, like debris coverage, which meant 70% of erosion, something like that. And I like using it to show farmers, or like to show myself how little I needed to have the soil covered, because like farmers don't like that much debris on their field sometimes, even though we're pushing them to get it. So just like a little debris and hot.
That's a really good point, and I think in Vermont, like for our phosphorus index, I think like 25% might be kind of the threshold where we see the real benefit of soil cover in the model. So yeah, definitely valuable in that sense.
So these all have the small tips on them. So like the gauge will have has a 1/2 inch and 3/4 inch tip.
Okay,
so
yeah.
These are all the 1/2 inch.
Okay, so we'll read off of the inside dial and just push straight down.
Yeah. And then
I think I'm like on a rock. I could feel some gravel in there.
Yeah.
well, yeah. So
Yeah,
it's
that's like
constant.
How far down do you go? Oh, that's great.
Plus, so I mean, you
so
can gauge,
like it's like at like 200 right there.
yeah, and that's
Oh,
to get
just
to a
keep
certain
going?
depth. And
Oh,
then
I
push
see.
in
So
and
when you
down.
it's when you put the pressure on is when you get the reading?
Yeah, exactly.
All right, so if I'm in the, so you said this is 1/2 inch tip?
Yeah, so like this one you can swap out. Here's the larger tip, so like you could use the larger
Okay.
size. I don't think the rest of them have that there.
And so this says, so what is it telling me in the?
What's the advantage to using one or the other?
That's a good question. I don't know. The gauge has both, so
Yeah.
like you can use both.
Seems like it's a little bit more fine grained. Like there's more. The spread is bigger. You know what I mean? I
It's
can't
probably,
articulate it, but
I know what
Yeah,
you
you
mean,
probably see
yeah.
less dramatic change, right? If you
Right.
use the larger tip.
How does this account for like variability in personal strength of the person using it?
Well, I mean, I guess you may not. Yeah, if you're,
Like,
if
no,
you're not strong,
totally,
yeah.
totally makes sense.
If you're not strong enough, you may not be able to max it out, right?
Like, what if I physically can't max it? If somebody can't max it out, does it matter?
I don't think that. I mean, it, you know, depends on.
this is like 200
So-
pounds. Like
So what's
no.
my goal?
Like-
What am I doing?
Well, so I mean, you can use this for a couple different things. Like if you were, you know, you can use it like to find compaction, you know, within a field. Especially, you know, it's usually pretty obvious though. You could also, some soil health tests may want to know like what, how many pounds of force it takes to get to a certain depth of penetration.
So it tells you where your compaction is in the soil. So is
Yeah.
it hitting the hard pan? We're not looking at that, are we? We're just.
Well, yeah, you could be, but this, you know, we're in this disturbed area. I mean, if we went out to the field, you could look at
Like
find the depth of the hard pan.
it might over there. It's
So I
a
don't
little
know.
less compacted on the top. Like there's a compacted top layer here. Yeah.
Well, I mean, you might be more so. So like,
Get over here.
I guess that might depend on.
When I hit the gym.
A lot of it is just weight.
Yeah.
I think that it's like I got to like 200 pounds right there.
I'm like almost
Yeah.
to